First we will see. Suppose if I take a digital sum, DS means digital sum. Digital sum is nothing but the sum of the digits till a single digit is obtained. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means if I take 91, what is the digital sum? 9 plus 1, 10. 1 plus 0, 1. 181, what is the digital sum? 1 plus 8, 9. 9 plus 1, 10. These is a set of all the numbers whose digital sum is 1. 332. What is the digital sum? 9 plus 2, 11. It is 2. So first is set of all the numbers whose digital sum is 1. Set of all the numbers whose digital sum is 2. Set of all the numbers whose digital sum is 3. Set of all the numbers whose digital sum is 9. You cannot have digital sum 0. Sum of the digits at 0 is illogical. 1 square, which is 1. 2 square, which is 4. 3 square, which is 9. 4 square, 16, which is nothing but 7. 5 square, 25, which is nothing but 7. 6 square, 36. 3 plus 6, 9. 7 square, 49. 4 plus 9, 13. 1 plus 3, 4. 8 square, 64. 6 plus 4, 10. 1. 9 square, 81. 8 plus 1, 9. So what are all the right hand sides we got? 1, 4, 9 or 7. Please write down, sir. Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. But all the numbers with the digital sum, 1, 4, 7 or 9, 1, 4, 7 or 9 may or may not be perfect squares. May or may not be perfect squares. Very, very important point, sir. May not be perfect squares. Please write down. If a number is a perfect square, if the number is a perfect square, it will have digital sum 1, 4, 7 or 9. But if the number digital sum is 1, 4, 9, 7 or 9, it may or may not be a perfect square. Example, 25. 25 is a perfect square. What is the digital sum of that number? Digital sum is 2 plus 5, 7. But if you take 61, what is the digital sum of 61? 7. Is it a perfect square? It is not a perfect square. If I take 16, it is 7. It is a perfect square. Reverse case may or may not be true. If a number is a perfect square, it should have digital sum 1, 4, 7 or 9. It should have digital sum 1, 4, 7 or 9. But the reverse may or may not be true. If the number is a perfect square, it should have digital sum 1, 4, 7 or 9. But if a number has got digital sum 1, 4, 7 or 9, it may or may not be perfect squares. Please write down few examples. Is 1, 2, 3, 3, 2, 1. Is 1, 2, 3, 3, 2, 1 a perfect square? Is 1, 2, 3, 3, 2, 1 a perfect square? What is the digital sum of these number? Digital sum of these number is 6 plus 2, 8, 8 plus 1, 9, 11, 12. 12 is 3. A perfect square will always have digital sum 1, 4, 7 or 9. Always have digital sum 1, 4, 7 or 9. Second example is 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 4 a perfect square. A perfect squares. 1, 2, 2, 3, 3, 4, 4, 4, 4, 4 a perfect square. What is the digital sum of these number? Digital sum of these number is 1 plus 2 plus 2, 4, 3 plus 3 plus 3, 9, which is 16, which is 30. 30 is 3. It is not a perfect square. It is not a perfect square. I hope it is clear. How many? Third question. How many 2-digit perfect squares? How many 2-digit perfect squares has a digital sum? How many 2-digit perfect squares has a digital sum? 5. How many 2-digit perfect squares has a digital sum? 5. Now if you see here, how many 2-digit perfect squares? If a number is a perfect square, the digital sum should be 1, 4, 7 or 9. So, but the digital sum is 5. Every perfect square has a digital sum, 1, 4, 7 or 9. But he is asking for digital sum 5. So, answer is no number exists. No number exists. No number exists. I hope it is clear. Next one, fourth one. Please write down, sir. Fourth one. How many 2-digit numbers? How many 2-digit numbers? How many 2-digit numbers has a digital sum 3? How many 2-digit numbers has a digital sum 3? How many 2-digit numbers has a digital sum 3? Now see here. Good question, sir. How many 2-digit numbers has a digital sum 3? What is the... There is a number and this number digital sum should be 3. This number digital sum should be 3. What is the lowest value that will have digital sum? 3, n is 3. If I add 9 to it, 3 plus 9 is 12. 12 digital sum is 3. Again, if I add 9 to it, 21 it is 3. 30 it is 3. 39 it is 3. 48 it is 3. So, the form of that number will be, lowest is 3. Every time if I add 9, digital sum will not change. Form of the number is 3 plus 9k. K will not take 0 because if it takes 0, I will get a single digit number. K will take from 1 to 10. K will not take any value from 11. Why? Because 11 9s are 99. 99 plus 3 is 102. So this will have all the values from 1 to 10. There are 10 numbers. There are 10 numbers that will have digital sum 3. I hope it is clear. How many 2-digit numbers? He is not referring to perfect square. He is referring to how many 2-digit numbers. A number lowest digital sum is 3. Every time if I add 9 to it, every time if I add 9 to it, every time if I add 9 to it, digital sum does not change. So the form of the number is 3 plus 9k. 3 plus 9k. I require 2-digit number, so k cannot take 0. K will be 1. 1 to 10. If k takes 11, 11 9s are 99 plus 3, 102. 102 it is a 3-digit number. So 1 to 10 all the values it can take. 1 to 10 numbers. So answer is write 10 values. I hope it is clear. Fourth example. Fourth one clear, right? Next one. Fifth one. X square minus 3y square equivalent to 8. X and y are natural numbers. How many values x, y will take? X square minus 3y square equivalent to 8. X, y are natural numbers. How many values x, y can take? Method 1. X square minus 3y square equivalent to 8. Observation. X square is a perfect square. Any number, if the power is an even number, it is a perfect square. Perfect square will have digital sum 1, 4, 7 or 9. These are the all the possible digital sums. These are the all the possible digital sums. I hope it is clear. Minus any number multiplied by 3. You multiply any number by 3. 3 2s are 6. 3 7s are 21. Digital sum 3. 3 9s are 27. 2 plus 7 digital sum is 3. Any number multiplied by 3, the answer possible digital sum is 3, 6 or 9. 3, 6 or 9. Any number multiplied by 3, any number multiplied by 3, digital sum will always be, digital sum will be 3, 6 or 9. If you multiply any number by 3, digital sum will always be 3, 6 or 9. Now if you observe, anywhere am I getting 8? What do you mean by digital sum? Digital sum is also nothing but the remainder when you divide a number by 9. This is an alternate definition. 1 minus 3 minus 2. Minus 2 means positive remainder 7. 1 minus 6 minus 5 positive remainder 4. 1 minus 9 minus 8 positive remainder 1. 4 minus 3 1. 4 minus 6 minus 2. Minus 2 means positive remainder 7. 4 minus 9 minus 5. If you get a negative remainder, add it to the denominator. Minus 5 plus 9 4. 9 minus 3 6. 9 minus 6 3. 9 minus 9 0. Anyway, after doing the operation, digital sum 8 not possible. Digital sum 8 not possible. I hope it is clear. Digital sum 8 not possible. Answer is no value for x comma y exists. Answer is no value for x comma y exists. Again I am repeating. X square is a perfect square. A perfect square will have digital sum. All the possible digital sums are 1, 4, 7 or 9. 3 into, these 3 into, y square is also a perfect square. All the possible digital sums are 1, 4, 7 or 9. 3 ones are 3. 3 is a possibility. 3 fours are 12. 1 plus 2, 3 is a possibility. 3 sevens are 21. 2 plus 1, 3 is a possibility. 3 nines are 27. 6 anyway, this can be eliminated here. Because any number multiplied by 3, it is 6, 3 or 9. But if it is multiplied by perfect square, there is no question of 6. One more step can be eliminated. Now if you see, 1 minus 3 is minus 2, not possible. 1 minus 9 is minus 8, I want plus 8. 4 minus 3, 1, 4 minus 9, minus 5. 7 minus 3, 4, 7 minus 9, minus 2. 6 and everything, not possible. Good question based upon perfect squares logic. Method 1. Method 2. X square minus 3y square equivalent to 8. Now I am discussing a new approach. Ax square plus or minus by square equivalent to n. How to find out the integral solutions? How to find out the integral solutions of this form? Ax square plus or minus by square equivalent to n. So what we have to do is, same thing sir, x convert in the coefficient of y square, y convert in the coefficient of x square. Listen carefully. X will take the coefficient of y square. What is the coefficient of y square? 3. When you divide a number by 3, either it will be perfectly divisible, or it will give a remainder 1, or it will give a remainder 2. Are you with me? X should be converted in the coefficient of y square. X when you divide by 3, perfectly divisible, gives a remainder 1, gives a remainder 2. Only these 3 cases. 3k whole square minus 3y square, divisible by 3, divisible by 3. Answer should be divisible by 3. 3k plus 1, 3k plus 1 whole square minus 3y square, which is 9k square plus 6k plus 1 minus 3y square, divisible by 3, divisible by 3, divisible by 3. When you divide by 3, it gives a remainder 1. 3k plus 2 whole square minus 3y square. This is nothing but 9k square plus 12k plus 4 minus 3y square, divisible by 3, divisible by 3, divisible by 3. 4 when you divide by 3, remainder is 1. Answer, when you perfectly divide it 3 or it gives a remainder 1. 8 is 3 into 2 plus 2. That form will not arise. That form will not arise. Answer is no value for x comma y exists. No value for x comma y exists. Again I am repeating. Nothing to do sir. Just looking at a question, you will get the answer once you understand the root cause. X should be converted in the form of coefficient of y square. Coefficient of y square is 3. When you divide a number by 3, perfectly divisible, it gives a remainder 1, it gives a remainder 2. So 3k whole square minus 3y square, divisible by 3, divisible by 3. 3k plus 1 whole square minus 3y square, 9k square divisible, 6k divisible, 3y square divisible. It gives a remainder 1 when you divide a number by 3. 3k plus 2, 3k whole square divisible by 3, 12k divisible by 3, divisible by 3. 4 when divided by 3, it gives a remainder 1. Answer means when you divide by number, right hand side is, when you divide a number by 3, you should get 0 or 1, but you are getting a remainder 2. Answer is no value. Answer is no value. I hope it is clear. We will do some more questions. X square plus 4y square equivalent to 1379. XY are natural numbers. XY are natural numbers. How many values XY can take? X square plus 4y square equivalent to 1379. XY are natural numbers. How many values XY will take? See here. X will be converted in the coefficient of y square, 4. When you divide a number by x, perfectly divisible by 4, it gives a remainder 1. It gives a remainder 2. It gives a remainder 3. This is nothing but 4a whole square plus 4y square. Divisible by 4, divisible by 4. Answer will be divisible by 4. 4a plus 1 whole square. 4a plus 1 whole square plus 4y square. You don't need to do. 4a square divisible by 4. 2 into 4a divisible by 4. These divisible. 1 square, remainder 1. 4x, or you write like this. When you divide a number by 4, what are all the cases? Here you are getting perfectly divisible. I am getting a remainder 1. 4a plus 2 whole square plus 4y square. Think logically, sir. 4a square divisible by 4. 2 into 4a into divisible by 4. These is divisible. Again 0 or 1 you are getting. 4a plus 3 whole square plus 4y square. 4a square divisible by 4. These is divisible by 4. 9 when you divide by 4, remainder is 1. Only I am getting right hand side, either remainder 0 or remainder 1. 13, 17, 9. 4 19s are 76, which is 4k plus 3. 4k plus 3 form does not arise. Answer is no value for x comma y exists. No value for x comma y exists. I hope the idea is clear. Any doubt in this idea? No value for x comma y exists. Still I will make you solve right questions just orally, sir. All you require is just a basic understanding of the concept. When you divide x by 4, perfectly divisible, remainder 1, remainder 2, remainder 3. So from now onwards, if it is x square, we'll forget all this. 1 square is 1, I will get remainder 1. 2 square is 4, I will get perfectly divisible. 3 square is 9, it gives a remainder 1. 1 or 0. 79 is 4 into 19 plus 3. So answer is no value for x comma y exists. No value for x comma y exists. Same question. One more question I will do. X square minus 5y square equivalent to 1, 2, 3, 2. XY are natural numbers. How many values XY will take? We already did it by using perfect square logic. X square should be converted in the coefficient of y square. 5a, 5a plus 1, 5a plus 2, 5a plus 3, 5a plus 4. These are all or nothing but the various forms x will take. Square, square. 5a square divisible by 4. 1 square divided by 5, remainder 1. 2 square, 4 divided by 5, remainder 4. 3 square, 9. 9 divided by 5. 5 2s are 10, minus 1. minus 1 means plus 4. 4 square is 16. 16 divided by 5, positive remainder 1. Right hand side, it should give either 5p plus 1 or 5p plus 4. 5p plus 1 or 5p plus 4. So what is the unit digit? Right, unit digit should be either 0 or 5. So 2, 5p plus 2. Answer is no value for x comma y exists. Are you all with me? I hope you understood the idea. Seems a very difficult question, but with a logic you can hit it in seconds. X square and 5y square. I hope it is clear. Now we will do some more questions. We will try to answer that questions in 5 seconds, 10 seconds. 4x square plus y square equivalent to 1739. 1739. 5x square plus y square equivalent to 2352. XY are natural numbers. XY are natural numbers. Some beautiful questions developed to make you understand the power of using number tree. XY are natural numbers. How many values XY will take? Just by looking at a question, you can say that it is 4. So it will be 4a, 4a plus 1, 4a plus 2, 4a plus 3, y. All are square. So 4a square divisible by 4. 1 square 1, it will give a remainder 1. 2 square 4 divisible by 4, 9 square. So answer should be either divisible by 4 or it should give a remainder 1. 39. 4 9s are 36 plus 3. Answer is no value for x comma y exists. No value for x comma y exists. Next one, this is 5a square. 5a, 5a plus 1, 5a plus 2, 5a plus 3, 5a plus 4. So if I square it, divisible by 5, 1 square it gives a remainder 1, 2 square 4 it gives a remainder 4, 9 when divided by 5 minus 1 positive remainder 4, 5p plus 1, 5p plus 4. Answer is no value for x comma y exists. No value for x comma y exists. If the right hand side satisfies any of this one, then we are going to solve how to find out the value of x and y in polynomial equations. In polynomial equations, I will discuss if the right hand side is when you divide by 4, it gives perfectly divisible or it gives a remainder 1. I hope the idea for this question is clear. Next one, this question please write down. X power 6 plus y power 6 plus z power 6 is 2002. One student asked me this doubt. X, y, z are natural numbers. How many values x, y will take? How many values x, y will take? X power 6 plus y power 6 plus z power 6 equivalent to 2002. How many values x, y will take? Now see here. What we will do is, what is the right hand side digital sum? Digital sum is nothing but 4. Digital sum is nothing but 4. So I will divide x power 6 divided by 9. X power 6 divided by 9. Method 1. When you divide a number by 9, what are the reminders possible? 0, 1, 2, 3, 4, 5, 6, 7, 8. Am I right? 0 divided by 9, it is 0. 1 divided by 9, it is 1. From here to here, 3 divided by 9, it is 0. Right? Now 6 divided by 9, 6 is, right? I hope it is clear. So this will become 3 power 6 divided by 9, remainder is 0. 6 power 6 divided by 9, remainder is nothing but 2 power 6 into 3 power 6. Again the remainder is 0. I hope it is clear. Remaining all the logics, remaining 2 power 6 by 9, remainder 4 power 6 by 9, remainder 5 power 6 by 9, remainder 7 power 6 by 9 and remainder 8 power 6 by 9. All the cases if you observe, 64 divided by 9, remainder 1. 9, 5 cube, 5 power 6 is 5 cube whole square divided by 9. 5 cube is 125. 9 14s are 126. Minus 1 square is 1. Here I will get 1. Here I will get 1. Here 4 power 6 I will get 1. Are you all with me? Here also I will get 1. Here also I will get 1. So idea is to tell you that you don't need to do all this, sir. You don't need to do all this. Directly you can say, please write down, sir. X power 6 plus y power 6 plus z power. This is a doubt asked by a student in WhatsApp, sir. This came in one of the CAT mock papers, it seems. One page solution is there. You don't need one page solution. If you listen to my class, it takes 5 seconds. Remainder 1, x power 6 divided by 9. It will be 0 or 1. 0 or 1. When it will be 1? When x and 9 are co-prime to each other. When x and 9 are co-prime to each other, according to quotient function, a power 5 of n by n equivalent to 1. So, a power 6 divided by 9 is 1. What is the quotient? 9 equivalent to 3 square. 5 of 9 is 9 into 2 by 3, which is 6. Go through the remainder class, you will understand this concept. When x and 9 are not co-prime. Not co-prime means x contains the factors of 9. So, x power 6 divided by 9 is 0 or 1. Similarly, y power 6 divided by 9 is 0 or 1. Similarly, z power 6 divided by 9 is 0 or 1. So, what are all the maximum reminders that I will get? 1 plus 1 plus 1, 3. What is the digital sum of this question? 4. So, answer is no value x comma y exists. No value x comma y exists. Good question, but only thing is that you should know these Euler quotient function. Then the question can be solved in 5-10 seconds. Euler quotient function is used when the denominator is a composite number. Students who have attended all my reminders class, you can solve it. Remainder 1, x power 6 divided by 9 is 0 or 1. X and 9 are not co-prime. Take x equivalent to 3. 3 and 9 are not co-prime. X power 3 power 6 by 9 is 0. Take x equivalent to 2, which will satisfy this condition. 1. 2 power 6 is 64. 64 divided by 9. 9 sevens are 63. 1. Please write down these points. Please write down this point. X power 6 divided by 9 is 0 or 1. When I will get 0? When x and 9 are right not co-prime to each other. When I will get 1? When x and 9 are co-prime to each other. When x and 9 are co-prime to each other. X became y. Y became z. 0 or 1, 0 or 1, 0 or 1. Maximum value it can be is 3. But the right hand side is 4. Answer is no value x comma y exists. I hope the idea is clear. Key point 2. Key point 2. Perfect square always will have digital sum 1, 4, 7 or 9. Then we will see. First we will understand, then we will write down the key point. Now see here. Suppose if I take the digital sum of a number, these 1, these 2, these 3, 4, 5, 6, 7, 8, 9. If I cube it, 1 cube is 1, 2 cube is 8, 3 cube is 27, 2 plus 7 it is 9, 4 cube is 64 which is 1, 5 cube is 125, 1 plus 2 plus 5 8, 6 cube is 216 which is 9, 7 cube is 343 which is 1, 8 cube is 512 which is 8, 9 cube is 729 which is 9. Very, very important key point. Same like perfect square. Every perfect cube, key point 2. Every perfect cube has a digital sum. Every perfect cube has a digital sum 1, 8 or 9. But all the numbers with digital sum, all the numbers with digital sum 1, 8 or 9 may or may not be perfect cubes. Please write down. May or may not be perfect cubes. May or may not be perfect cubes. Very important learning. If a number is a perfect cube, it will have digital sum 1, 8 or 9. But if the number has got digital sum 1, 8 or 9, it may or may not be perfect cubes. Idea clear? Every perfect cube has a digital sum 1, 8 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect cube has a digital sum 1, 8 or 9. One example. Same idea, sir. Idea remains the same. Structure remains the same. Is 1, 5, 3, 4. Is 1, 5, 3, 4 a perfect cube or not? Is 1, 5, 3, 4 a perfect cube or not? 7, 12, 13. Digital sum is 3. A perfect cube has a digital sum, right? 1, 8 or 9. 1, 8 or 9 is 333, 999, 4 twos, 1, 92, 92. Is it a perfect cube or not? These same somewhere in some examination, sir. Is it a perfect cube or not? Out, 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 out. 2. So the digital sum is 2. For it to become a perfect cube, it should have digital sum 1, 8 or 9. 1, 8 or 9. I hope the idea is clear. Perfect square over perfect cube over. Key point number 3. Please write down. Key point number 3. X cube 50 plus x whole cube. X cube 50 plus x whole cube has the same last 2 digits. Has the same last 2 digits only if x is even. Please write down. Very, very important key point. X cube 50 plus x whole cube has the same last 2 digits only if x is even. Please make a note of this important key point. X cube 50 plus x whole cube has the same last 2 digits only if x is even. In the form of square we did x square 50 minus x whole square, 50 plus x whole square, 100 minus x whole square, 100 plus x whole square has same last 2 digits. There is no restriction on x, but here there is a restriction. Why? Proof. 123. If I take an example 123, reminder, when you divide a number by 100, 100 ones are 100, remainder is 23. This is nothing but the last 2 digits of a number. This is nothing but the last 2 digits of a number. Last 2 digits of 123 is 23, which is nothing but the remainder when you divide a number by 100. 100 ones are 100, remainder is 23. So 50 plus x whole cube, a plus b whole cube, a cube, 3a square b, 3ab square, ab square, and next is b cube. Now if you observe 50 cube is nothing but divisible by 100. 50 square divisible by 100. X is an even number. Even number is 2k. 3 into 50 into 2k whole square. 4 into 50 divisible by 100. What is left? x cube. Very, very important point. X cube 50 plus x whole cube has the same last two digits only if x is even. Only if x is even. X cube 50 plus x cube has same last two digits. It will have same last two digits only if x is even. I hope the proof is clear. 50 cube is divisible by 100. This is divisible by 100. Even square into 50 divisible by 100. This is becoming divisible by 100 only if x is even. I hope it is clear. That is the reason finally I wrote a point. X cube 50 plus x whole cube has same last two digits only if x is even. Example. Example. How many two-digit numbers? How many two-digit numbers on cubing ends with 28? How many two-digit numbers on cubing ends with 28? How many two-digit numbers on cubing ends with 28? There is a number, it seems, x on cubing. It will end with 28. It will end with 28. X cube is ending with 28. So x values can be 2 cube. 2 cube is 8, but I want 28. Next number is 12 cube. 12 cube is 1728. Yes, the last two digits is 28. What is the logic we discussed? X cube and 50 plus x whole cube. Last two digits will be same. Last two digits will be same only if x is even. Only if x is even. Only if x is even. So these nothing but 12 is even. So what are the two numbers? 12 cube and the next number is 62 cube. Idea clear? How many two-digit number on cubing ends with 28? It is ending with 8. If it is ending with 8, x has to be 2 because we discussed the logic. A perfect square never ends with 2, 3, 7 or 8. On cube, it will come from 2, 3, 7 or 8 from bottom to top. I hope in session number 2 we discussed this. So, for it to become 8, x has to take 2. Lowest number is 2 cube 8. Next number is 12 cube, which is 1728. Which is 1728. I got 28 at the end. So, number will be 12. Next number will be 50 plus 12, which is 62 cube. You don't need to do it. These both the numbers, even if you use by using a plus b whole cube, last two digits will be same. In case if you want to cross check it, 3 into a into b square and b cube, these 8. 3 6 are 18, 8. 8 into 4, 32. So 32 is 2. I hope it is clear. What is this one? This is nothing but 3ab square and b cube. Last two terms only we require, right? 3ab square and b cube. Idea is clear. One more question. Please write down, sir. One more question. Very easy once you understand the concept. But you should know all this. If you don't know only, you will get into a problem. X cube 50 plus x whole cube. Last two digits will be same only if x is even. Next one, how many three-digit numbers? How many three-digit numbers on cubing ends with 44? How many three-digit numbers on cubing ends with 44? How many three-digit numbers on cubing ends with 44? Just if you do logically, you will get, sir. There is a number on cube. It is ending with 44. X cube is ending with 44. X has to be 4. Slowest number is 4 cube, 64. I want 44. Next is 14 cube. If you use a plus b whole cube, you will get 2744. So last two digits is 44. So what is the logic? x cube, 50 plus x whole cube. Last two digits are same. X cube and 50 plus x cube. Last two digits are same only if x is an even number. X is 14. It is an even number. So 14 cube. Next it is 50 plus 14. 15 plus 14, 64 cube. But I require a 3-digit number. So in 14, these hundreds place can become 1, 2, 3 till 9. 114, 214 and 7 whole cube. This is a 3-digit number. Hundreds place can become anywhere from 1 to 9 ending with 64 cube. 14 cube or 16 cube. So 9 numbers plus 9 numbers. 9 plus 9, 18 numbers. 18 numbers on cubing, I will end with 44. Sir, how you got this one? You think logically, sir. Lowest is 14. Next is 64. If I take x as 64, what is 64 plus 50? 114 cube. If I take it as x 114, 164. Again if I add 50, 214. Again if I add 50, 264. And so on. 914 and 964. So here 1 to 9, here 1 to 9. What is 9 plus 9? 18 numbers. I hope the logic is clear. Generally, if you see any of the books, there will be a one-page solution for this. But entire concept can be simplified because of this concept. Last x cube and 50 plus x whole cube. Last two digits will be same. Last two digits will be same if x is an even number. If x is an even number.